I have two axes over here, x-axis and the y-axis. And on these axes, you can basically see sort of three different curves, if you want to call them. Actually, you can see two curves in a line. So we have a parabola, which is a curve, and then we have a cubic graph. We have a cubic graph, and we have a line. And what I want you to do is I want you to tell me, can you find the gradient of the parabola, and can you find the gradient of the cubic graph? Now, if I ask you to find me the gradient of the line, you can do that fairly easily. All you have to do is choose any 2 points on the line. So let's say you choose this one, and you choose this one. Let's say the coordinates of this guy are x1 and y1. My bad, x2 and y2. And the coordinates of this guy are x1 and y1. And so you'll say, well, it's really easy. The gradient m is just going to be y2 minus y1 over x2 minus x1. And you're like, well, that's how you find the gradient for a line. But well, while that is correct for a line, you can't really do that the same for a parabola or a cubic graph. Why? Because, well, they're not lines, they're curves. And every single point on a curve has a different gradient. So if I just talk about my parabola, this point is going to have a different gradient, then this point is going to have a different gradient, then the point next to it, and then the point next to it, and then next to it, and then so on. This entire parabola has a different gradient on each of its points. In the same way, if I look at the cubic graph or the cubic curve, this point is going to have a different gradient, this point is going to have a different gradient, this guy is going to have a different gradient, and so all of the points on this cubic graph are going to have different gradients. With lines, we sort of have this edge that the gradient is the same for all of the points. For curves, we don't do that. So how do we find the gradient of a point on a curve, whether it's a parabola or a cubic graph or some other curve? How do we do that if we cannot use our gradient formula? And well, that's where differentiation comes in and saves your life. So that's actually where differentiation comes in. And it basically gives you this, it's a mathematical tool that allows you to sort of use its power and sort of find the gradients of the different points of curves. So that's basically this special power of differentiation. It allows you to find the gradient of different points on a curve. So for example, if you go back to my parabola and let's say I pick this point and I ask you to tell me what the gradient will be at this point, then how you can do that is you can basically use differentiation and you can tell me what the gradient is going to be at that point. If you go over to the cubic graph, you can pick up a different point, let's say this one, and again, you can use differentiation to tell me what the gradient is going to be at that point. So differentiation is all about finding gradients at different points of curves. And while your gradient formula worked only for lines, so this was only for lines, differentiation actually works for lines and curves. So you have your lines and you have your curves. So it doesn't matter what your graph looks like, you can differentiate it and you can find its gradient at any point.